All right, welcome to another coding session. This time I'm coming to you from Bali, and I have to admit that the Bali atmosphere is not so conducive to getting things done. I've been procrastinating doing more coding sessions, but let's give it a go, hey? I think I have something interesting that I want to try. I had thought about doing floats, and I did a bit of work towards it, but it's a big beast, and I thought maybe I'd start with something a little more different to what we've been doing recently, a little more interesting. So I've got the grammar open here, and what I want to do is just kind of make a few improvements here, a few changes, because there's a few things that I've been not that happy with, and I do want to slowly move away from, because at the moment it's very much based on Odin, you know, where I wasn't sure what to do. I just kind of copied Odin, and I want to move away from Odin to give the language a bit of its own character. So I'm not sure if we're going to be able to do too much of that today, giving it its own character, but we're going to do a bit of foundation work maybe, and a few improvements. And the first thing that has been bugging the most is the for loop. You know, the way that this is structured here, where at the moment I've said you can either have an expression or you can have declaration, comma, expression, comma, assignment. And the problem with that is that then when we model that in code, if we code exactly this, it's a bit not so nice. And it could be a little more flexible. Like maybe you can have a declaration and an expression, but not an assignment. What's wrong with that? Yeah. So let's change this grammar a little bit to something more like what I want to have. So we have our for loop here. So we don't want to have this expression, or I guess we don't need the bracket. No, we'll keep the bracket there. So there's declaration, comma, and then I'll put a closing bracket and say that's optional. You can put declaration, comma, you don't have to. You do have to put expression. And then again, optionally, you can put comma, assignment. So I'll put a question mark there. And then of course you always need the scope. So that already looks quite different, doesn't it? So we have the for keyword. Optionally, we can have declaration followed by a comma. Always have an expression. And then optionally, we can have comma followed by an assignment. And then we have our scope. I think that's much nicer. Tokenization, I don't think we're going to need to touch in this video. Yeah, I'm not really sure. I doubt that we'll add any tokens. You know, it's more about parsing. Well, parsing forward, I guess, it's going to affect these other steps too. So if we go to our for, parse for, there's parse if, parse for. What's the difference here? So previously we had the two cases, right? This case is saying declaration, expression, assignment, and this case is just expression. So I think we can take this case off, and this is checking to see if we're starting with a declaration, and if we are, then we need to do parse the declaration and the comma. We always parse an expression, and then we need some sort of condition here to check whether we do the assignment, because this comma assignment is also optional now. And because we start with a comma, like up here we have to like do this stuff which I don't really like, and at some point I think we need to resolve and make a bit better. But if you have an identifier followed by a colon, that means it's a declaration. because the declaration comes first. We need to make sure that it matches a declaration. But here, because the comma comes first, all we have to do is say, is there a comma? So I think that's it, really. I think that's a bit nicer, a bit more flexible. So then type checking, let's have a look. Scope 4. So again, we're saying, is there a declaration? And if there is, then we do like declaration expression. Interesting that we put this right at the end. Not quite what I expected. But this case here is if there's only an expression. Let's just cut that out for now. And maybe we'll put this here. And at the moment we've got like hard-coded indexes for these things. I think I want to change to this pattern, yeah, like this, that I use in other places. And maybe I'm just going to call this child node because, yeah, because I think we're not sure exactly what it's going to be. So if it is a declaration, then we type check that. Yeah, this is an issue. Maybe we can solve this at the same time. I guess due to refactoring, things have changed and this looks a bit out of place. Like, what is it talking about? What it's talking about is that we have a declaration here. And in this declaration, we're going to, here we go, we're going to add a variable to the scope. The problem with that is, see, here's an example for loop like this. So we have this declaration. We should be able to do this. This should be valid because this should be scoped to the for loop. It shouldn't exist after the for loop. But because we add it to the context, and then that context, you know, it's the context that gets passed in, it exists after the for, and it still has that variable in it, then effectively that means that the variable is not scoped to the for loop. So I think what I'm going to do is copy the type checking context and we'll pass in true. I think we need to dereference this. We'll pass in true to say that it's inline, and that means that any variables in this context will also be in this context, because we want things within the for loop to see things that were outside the for loop. And then we use that, maybe I should say CTX, it's consistent. I always use CTX for context. And then we probably need to use a pointer. And then everywhere in this procedure where we use context, now I want to use that for context. So all these other parts of the loop can access this declared variable. But then when we leave the for loop and we go back to using this context, it does not know about the variable, so the variable is scoped correctly. Okay, hopefully that works. So now, because we did this declaration, after that we want to go to the next node. And now the current node should be an expression. So we process that. After the expression, we go to the next node. And this is where it's a bit funky. I'm not sure why we have scope first and then assignment. So let's move this up here. This makes more sense to me. So if that node that we've gone to now is an assignment node, then we type check the assignment. And again, we put in here to go to the next node. Now we should be at the scope node, like so. So I think that makes more sense. We do the declaration if we need to. We always do the expression. We do the assignment if we need to, and we always do the scope. And we're using our own context, so this code should be valid. We should not get an error anymore. So now that we've changed the way the for loop works a little bit, we are going to need to change the generation as well. For I guess again we're going to need to have this kind of pattern, and then we'll go if we're looking at a declaration. We have this comment here. I think this might have just been copy pasted from the other file. I don't think that really matters here. We don't need it to be a pointer. We don't modify nodes in generation. We're just using the information from them. Okay, so this is already doing the expression node. Yeah, and this was the other case if it was just an expression. So now this, I think, is part of the expression stuff. So we generate a declaration if we need to, and then we put our for label, because if we loop up to the top of the for loop, we don't want to loop above this declaration. And even if the declaration doesn't exist, we still need to be able to loop up to here, so this is the top. We need to skip to the next child. So that's our expression node is the current child. Like so. So this is the expression code. Here is this. So again, we have this. Okay. I think I know why in type checking we had it in this funny order before. I think it was just to be consistent with generation, because generation, like the way a for loop works is that this declaration, well, no, this assignment, this assignment here needs to happen at the end of the loop. See, it's equivalent to this. Here we have it at the end of the loop, here we have it here, but they both need to be executed at the same time. So the assignment needs to be at the end of the loop, which means after the scope. So when we're generating, we do need to do it in this order. I think we can, like from after the expression, we skip to the next node. This may be the scope node already, or it may be an assignment. So I think we'll check whether it's an assignment, and if so, we'll generate the assignment. And then the scope, I'm always just gonna, the last node in a for loop has to be the scope. So I'm just always gonna say, get the last child as the scope node and generate the scope. And then we have a bit more. This is jumping back to the top of the loop, and this is how we exit the loop as we jump. So we jump to the end label. So I think that's right. What happens if I run that? So it still works. That's nice. I think I might move. I'm going to move these for loops. And this worked, so that's really great. I'm going to move this stuff into my test file. I'm going to try and do a few different variations. So let's say for eSum, I'm going to say E for expression. This for loop only has an expression. And for E, I don't know, value. I feel like index is not right. And then after the loop finishes, we're going to assert that the sum equals, I believe it was 55. It should be 10 plus 9 plus 8 plus 7 plus 6 plus 5. Oops. So that's 45 plus 4 plus 3 plus 2. Oh, damn it. 52 plus 2 plus 1. Yeah, 55. Because that's what it does. It starts at 10 and we keep decrementing this value. Yes, we start at 10. So we add 10 to the sum, which starts at 0. Then we decrement it and add 9, decrement it, add 8, and we keep going until we get the value goes down to 0. So it should be 55. So test for expression. So now I'm going to say for declaration expression assignment sum. And I'm just going to call this for value. Since it's scoped, it should be fine. It's kind of a little test here. That should be valid. Not a duplicate identifier. So this is declaration expression assignment. So if I run, it's still all good. Oh, that should be for DEA sum. Okay, and now we can do some more variations now. So like we can do DE declaration. So that means that this one we put down here. And run that, and that should work. Undeclared identifier. So that needs to be DE. Yeah. And we can also do EA. So that means that this goes here and that becomes EA value. Expression assignment. So now we have the expression and an assignment. Here we have the declaration and an expression. I think these are all the combinations, so they all work. That's nice. Maybe while we're at it, let's just add a couple of tests. If I'm just going to make that an I8 of 0, and then I'm going to say if true, if I equals 1, and then I'm going to say if true, and then if false, I'm going to set it to 2, but it should still be 1 because it should not enter that loop. Okay, there's just a couple of like super basic. We've already tested kind of like expressions up here, so I don't think we need to do complex expressions. I just want to make sure that if it evaluates to true, it does the right thing. If it evaluates to false, it does the right thing. A couple of basic if and for tests. Okay, nice. So pretty happy with that. Then we got the for improved. There was another thing that I thought could be nice, because in a lot of places we use scope. So like a procedure has a scope here, if has a scope here and here and here, for also has a scope. And I kind of want to make that, instead of a scope, I feel like that could be just a single statement. You know, like I should be able to do like that. I think that would be nice. So let's try that, hey? I'm going to do this like if true, and it's kind of like if true single, if true single statement. So that should be 2, and I'll make that 3, but it should be 2. Maybe I'll make these tests a little more isolated. It's like if I true single, I'll make this like if I false and if I false single. So that should be 1, 0. 1, 0. But this is single, because it's a single statement. Okay, so at the moment that should throw an error because we're not allowed to do that. Yeah, it wanted the opening squiggling bracket, but it found just the statement. So I think what we can do for the if is just change the scope out so it could be this. And I think that should work in this context because what we're looking for after here is an else, which is a very unique keyword. It's not going to appear in here. Well, I mean, you could potentially have another if. Right? You could have if expression if, but I think that should work like that if would need to be all finished up and then we go to another else. So I'm just going to put statement here, I think. Statement, statement, statement. And let's see what happens. So if statement, statement, statement. Like so, and the statement can be a scope, right? So the scope should still work. It just means that other things can work now as well. So when we're parsing out if, this becomes a statement node, I guess, because it's like we're parsing a statement. Else if statement node, we're parsing a statement, and the else statement node. So that should parse it all. Type checking for the if. I guess we should also put some tests in here for like if else and else if and all that sort of stuff. Where were we? Type checking. So we do an expression. Then we get a scope. Well, this is actually a statement now. So we're going to type check a statement. Then we have this expression, and this is statement. So I guess this should also say statement. I don't think there's anywhere else where we reference the term scope in here. No. So basically anywhere where we see scope, we change to statement. Maybe I'll do underscore statement so I can also do that. Underscore statement. Like so. Okay. I think that works still. Now generation. So this is a statement node. So we need to generate a statement. Is it really this easy? I feel like this is too easy. I just swap out scope for statement and it just kind of works. Like, really? Okay. Okay. Is that it? Wow. That worked. Okay. Now I want to do some if-else. So if-else I true, false. Well, I guess it's just true. So if it's true, we go to 1. If it's false, we go to 2. Yeah, should be just that. And then the false version should end up as 2. And then we want like if else. Like so, and put another 3. That should still be like that. So that's kind of like true, true, false, true. Oh, I need to make sure that I'm using the right variables here. If I false, yeah, otherwise I'm not testing it properly. So this is false, true, so this should go 2. True, true, false, true. And now I want another case, which is false, false. And that should become 3. Cool. So that's a bunch of testing there. And then I think I might just test this last one again. I feel like the logic is all good. But I'm just going to do a single version. How did I mark that before? Single statement. So I should be able to just put it all on one line. I don't have to. Let's put it on multiple lines. Yeah, I should be able to just do this. Yeah, and it all works. Cool. Looks a bit weird, but it works. Nice. Okay. Pretty happy with that. Gives a bit more flexibility. Maybe then we can extend that to the for loop. Also have statement here, so that the for loop could contain just a single statement. So let's just change the grammar to say that. And let's go into parsing the for loop. What would it be? Here. Statement. Parsing a statement. I guess this will be even easier than the for loop because the if, because this is just in one place, right? Let's go statement, statement, statement. And then in the for loop we have statement, statement, statement. Everything still works as is. So we have all these different for loops. Let's take this one, sum single. And now we should be able to do something like this. Cool. I'm really surprised that that was so easy. I thought that was going to be more difficult. So one thing is like, one thing about this that I feel a little bit weird is like, if we put this on one line, I feel like this becomes hard to read. And I would like to be able to do this, because then for me it's much clearer. It's like, okay, this is all the condition stuff, all the for loop stuff, and there's the actual thing we're doing. Because sometimes you might just have like a really short one. And same with if statements. I feel like the brackets just give you a bit of separation that makes it a bit clearer. So I could optionally add brackets. I mean, for an if I go to this very first if, I'm pretty sure I could just do that. Yeah, it's fine, because an expression can be surrounded in brackets. But with the for loop, you know, this part is an expression. So I could put brackets here, but that's kind of not really what I'm looking for. And I like consistency. I'm wondering if I should just enforce brackets all the time. That's what a lot of languages do, right? Odin doesn't. But the idea is that we're going for our own character, right? And I think I'm going to enforce the brackets. So for an if, this expression needs to be wrapped in brackets. And for a for, all of this stuff needs to be wrapped in brackets. Let's do it. Decision made. Oh, he's just found a bracket character. So for the if, we want to wrap the expression of brackets, and for the for, we're going to wrap all of this stuff in brackets. If bracket expression bracket statement, else if, oh, this expression also I want to wrap in brackets. But this is wrap bracket. Yeah, so I think it's just that extra one for the if, this expression here. Okay, so now let's enforce that in our parsing. I think this is just parsing, isn't it? This is just parsing that cares about the brackets, because the AST is not, just doesn't give a shit about brackets. So parse expression, so it's kind of just like opening bracket. Oh, I think we need a different variation of that. Where is it? Like this. So it needs to have an opening bracket. And a closing bracket. I kind of want to keep that separate. And then this expression also needs to have opening and closing brackets around it. And then when we go down to the for loop, this expression also has to have brackets around it. So now we should get lots of errors like, yeah, because tokenization or parsing, once one thing goes wrong, it's like, we're done. So we're going to need to put like this. So the for loop needs to also have it in brackets. We also have an if here. Invalid token closing bracket, line 183. Interesting. Column 15. I expected a closing bracket, found a colon here. Huh. So maybe I did the for loop stuff wrong. Yeah, I was just saying the expression needs to be wrapped in it, but really it's like the whole thing. We need an opening bracket, then we need the declaration and the expression and the assignment, then a closing bracket. Yeah, I put it in the wrong place. Expected an opening bracket, didn't get one, so that's probably this file now. And because we have all those other tests, I think I'm just going to strip a bunch of this stuff out. It's kind of like, this is a bit of a playground here now. And a lot of that stuff we're just not really using anymore. I think I'll keep, I don't think my bool I use, but let's keep this stuff. And we need to put brackets around the for. There we go. Cool. Okay. We happy? We happy? What else was I thinking to do? Well, there's this one other place that the scope is used, which is the procedure call. Another thing I had in mind was like, I have grand ambitions to unify declaration and assignment and call, instead of being its own statement, should just be like a particular case of declaration / assignment, you know, like all sort of unified into one. That's quite grand. I think it's going to be a bit complex. So I think we're just going to try and like do some more stuff like we have been doing and not tackle that today because it's, yeah, I think it's going to be a pretty big one. So yeah, let's try the procedure call. Should be able to just put a single statement as the body. Doesn't have to be a whole scope. I guess another thing we could do for procedures is at the moment we require a return type, and we could change that so it's not necessary because, you know, sometimes you don't need to return. So first things first, let's make that a statement, like so. Procedure body is a statement. So then when we parse, we're parsing a procedure up here. Instead of parse scope, parse statement, like so. I'm kind of shocked how easy this stuff is, how it just kind of works. Now that I say that, it's probably not going to work. So this is the statement now, not a scope. So instead of scope context, I've been thinking that I want to rename this just to context, and we'll rename this to procedure context. I guess type check statement does not need a bool. What was it before? Scope. Why does scope need a bool? Include end label. Okay. Is there a harm to always including the end label? Wait a minute. Well, this is type checking. Why does this even exist? It's not actually used. So if it's not actually used, it's probably not an issue that we're not passing it in now. So where were we? Up at procedure. So we just renamed a bunch of stuff, and now we're doing type check assignment statement. Cool. Now to generation. Generating a procedure. So we need to generate a statement. So here we have this true. And this is where I think maybe it matters more. So if we go generate, where's our generate scope? Here we go, generate scope, include end label. So now it matters. Yeah. Okay, so maybe what I'm going to do, because now we're doing generate statement up here instead of generate scope, which then could go to generate scope. I'm going to make it that we do this and just pass it along because I think it is still necessary. If that scope is the body of a procedure, we need to be able to jump to the end. That's what the return, when we return, when we do a return, it doesn't actually directly return. right? So when we go in this procedure here, does it also, yeah, it has the return here. Yeah. So when we go into this, sorry, I'm jumping around a bit and getting lost. Where is the scope? Here. So we need to have this end label. So then if there is a return statement somewhere in this scope of multiple statements, if there is a return statement, we need to jump to here and clean up this scope. That's the idea. But now I'm kind of realizing that actually, because the procedure here is doing generate statement, it could be a single statement, which could be a declaration. We could declare something. And this, let's rename this also. Within the procedure context, so maybe actually what we need is to have something like this in the procedure as well. Like the scope itself could have some cleanup to do, but then the procedure also could have some cleanup to do. Because if this is not generating a scope and it's generating a single statement, which is a declaration, that's going to perform an allocation which we then want to clean up. Right, so that's where we would have like an end label for the procedure. And something like this. Which then makes me think that actually within the scope, we don't need this. We just need to make sure that we clean up anything with the scope. And here I also want to scope context, that's fine. Do some better naming. I think there's probably also the same thing here. Oops. And I think that makes sense. Like we were trying to do procedure-y stuff in the scope. Now the scope is just a scope. It's just a series of statements. And yeah, we make sure that the outer context keeps that information. Oh. We probably need to do that also in the procedure. And then we do this. Yeah, I wonder if there's some places where we've missed this. And then we need to clean up the scope. And then also when we're generating the procedure, we need to generate the statement. And then I think afterwards, in case this contained any ifs or fors, we need to pass that on to the parent context. So that we don't get duplicate ifs and for labels. Then we say this is the end. Here's our cleanup. But the problem with this is that then if we jump to end, if we jump to the end, then we're going to jump past this, aren't we? We're going to jump past that, and we're not going to clean that up. That's the problem. Okay. So this one is a bit more complicated. The other ones were so straightforward. This one has a little bit of something to it. So how are we going to resolve this? That end needs to come earlier, but it depends, because if this, it depends whether this was a scope or not. If it was a scope, then we want the end label to be in there, and if not, we want it to be out. Okay, so first things first, we need to restore this guy. Where was it? Here. And I guess we need to restore that. So there could be an end label there. And when we're generating statement, oh, sorry, this is the wrong place. This is if. But when we're in our procedure, we're generating our statement, we do want to generate this end label. So for generate statement, let's pass that along to the scope. And then maybe the way to do it is just to say, like, you know, if it wasn't a scope, if it was not a scope, then we do, and we're including the label. Where is it? Then we put it there. So it'll be after whatever statement there is. So if there's a scope, we make sure that it's before the scope cleanup. Otherwise, it's after the statement. If it's a single statement, it's either a return, which would skip to end. So I forgot to show that part. So return, all return does is skip to the end label. So let's think this through, actually. If we have a procedure that has a single statement, that either can be a return statement which says jump to the end, which is where we already are, there's no point. Or it could be a declaration, in which case we're also not skipping to the end, and it could be a declaration, so we're not skipping to the end, and then we should do this cleanup anyway. Yeah, if this output's just a declaration, then we just do that declaration and then it goes to this. Like, what's the issue? I don't think we need that. And I don't think we need this. I think it still is just that the scope has the end. Well, if it's a single statement and that statement is a return, that's pointless. Well, No, it's not, because we're returning a certain thing. It's not pointless, so we do, and because that return, its job is to go to end. Maybe we do need that, so that just so we know there's always an end label for it to jump to if it needs to. We have an issue. Oh, and we can't debug it. So that makes me think that it's not actually an issue in the compiling and stuff. It's like actually trying to run something. Well, it says failed tests. And I think if we open the main failed tests, yeah, it means that it tried to run the tests file and it failed. So something is wrong in the test file now. So we're playing with procedures. The only procedure here, like this is, yeah, there's lots of calls to the assert procedure. So that must be what it is. So here's the assert procedure. And what would we have changed? Well, that also calls another procedure within it called print. But print doesn't have all this logic. It's just a small hard-coded thing. It's this kind of stuff that we need to make sure is correct. So at the end, we return, we put a 1 onto the stack, and then we end. Yeah, because it's just returned true. And then this does some cleanup. Interesting that it adds 26, considering that is 25. So it feels like that will actually clean up past this return value. I think that's kind of correct, actually. Okay, let's maybe take that out and see what happens. Still an issue. So if I go comment all that stuff out, still an issue. So all the assert does, well, that's interesting. it deallocates a whole bunch of stuff, even though within this procedure nothing happened. Why would it be deallocating a whole bunch of stuff? That doesn't seem right to me. So let's have a look. So that'll be in this procedure here. So this cleanup, it's like, maybe it's because this procedure context, right, is like, it's not actually doing the allocating. It's just sort of saying like, hey, these variables exist and they're on the stack and stuff, you know. But it's not actually allocating the space for them, because that happens at the procedure call. So now now I'm deallocating space that was actually not allocated here. And the reason I'm doing that is because I just want to deallocate any space that this might have allocated. So we might have to do like improc true. Do I? Yeah, I do copy improc. So I might have to do like even another copy here. So like procedure body context is a copy of procedure context. Pass procedure body context in there. And it's actually this. So yeah, we made a new context just for this. Oh, we need to. Is that a thing for gen context? Yes. And did I do it up here? No, I guess you don't, because it's a procedure, so it doesn't see variables outside the procedure. But here we want to do inline true. Yeah. So this context exists just for the duration of this. And if after that is finished, yeah, it copies them down. So actually, need to do that. If this did some any allocation, then we deallocate it. Yeah. Yeah, so now we don't have that big deallocation that we had before. Hopefully that was the only issue. Let's try uncommenting this stuff and see if it still works. Cool, still works. Yeah, I wonder if we have a look at the assert now. Yeah, it's just got to return like, because there's no allocation in here. There's no allocation, so there's nothing to clean up. Yeah, there was nothing to clean up, but it was cleaning up a whole big thing. Cool. Okay. I think, let's close the main one. Don't use main file much. I think that's pretty good. We got some extra tests for our ifs and our fors. We made some alterations to the grammar for those, which I like. And we also made it so that, we never actually tested. We never actually tested doing a single statement. Okay, I was just getting ready to wrap up. Proc1, let's say, is proc and it just returns 1. So I guess we'll give that a type. So let's call it I8. And let's assert that equals 1. We'll just call it proc return. And then proc return single statement. So we'll call that proc1 single. We should be able to just do that. Which does look a bit funny. I do want to actually change how this works later on too. Let's just check if that works. Nice, it works. I'll give you a bit of a taster, what I'm thinking. So what I'm thinking is that this is like the type. So I want to unify the syntax. Like this is, most variables we do like this. And for procedures, we kind of have a special thing. So I actually want to do like this. That's how I want to do it. So it's still the same, it's like the name, colon, colon, and then the type. So where this type is just an I64, this type is a procedure that returns an I8. And then we're assigning this procedure body to it, to this variable. So I feel like that's more unified with this. And I also think as like a single line thing, that's clearer to read. There's more like delimiters, you know, like name, the colon is a nice delimiter, then we know this is the type, and then the equals, and then we know this is the body. So yeah, that's what I want to get to. But I think we've made some good progress today. And I like that we've got more tests for quite a lot of our stuff. So then, yeah, this file here, I really just want to be a playground. I don't want it to be some massive thing like it was before. And we've managed to make it smaller because most of the stuff is in here now as tests. Great. I'm happy. I'm happy with that. So yeah, thanks for stopping by. Have a good one. Ciao for now.